Hello, and welcome to this Smith Interconnect webinar. My name is Katie, and I will be your Global Spec moderator. Now let me introduce today's presenters. With us today, we have Joydip Sanyal. Joydip is the Product Line Manager of Circular and Rectangular Metal Connectors at Smith Interconnect. Also with us today is David Borsati. David is a Senior Sales Manager at Smith Interconnect. To read more about either of our presenters today, please look at the speaker bio window right next to the main presentation window. And with that, I'd like to pass things along to Joydip to get this webinar started. So go right ahead.
Thanks, Katie. Once again, hello and welcome to all the participants joining from different parts of the world. Trust you all are keeping well, safe in these difficult times. So, as Katie said, today the presentation, Davide and myself will kind of walk you through certain aspects of the challenges and opportunities of the next generation of connectivity, particularly when we look around complex electronic systems. And when we discuss this topic, we will look into how to reduce complexity of the system by focusing on the choice of connector. We will also discuss how to optimize design, for example, correct contact alignment, performance, and reliability of the contact technology to reach the necessary voltage. But before we start, it might be worth that to get you all engaged, let us take a quick snap poll. And I'll request kindly Katie to run this poll for us.
Okay, great. No problem, Joydip. So we do have a polling question for you all today. I will read the question and give you some time to answer, and then we will share the results. So the question today is, while designing a complex electronic system, how important is the choice of the connector to the overall architecture of the design? So you have a few choices here. A is extremely important, hence considered at early stages of the design. B is somewhat important and hence considered at mid stages of the design. And C is not important and hence considered at later stages of the design. So here is our ability to answer your polling question. If everybody would please take a moment to choose your answer, we'll give you some time to do that right now, and then we will share the results. So please go ahead and submit your answers. All right, everyone, I'll just give you another couple seconds to choose your answer. All right, great. So now we are going to move ourselves into sharing the results. All right, so Joydip, I'm going to pass it back to you. If you'd like to speak on the results that we're seeing here, go right ahead.
Yeah, no, thanks, Katie. This is exactly what when we exchange and discuss complex electronics in general, this is exactly what we see, that connectors do play an important role at the very early stages of the design, because the way everything gets connected ultimately defines the system architecture. So no, thanks for taking your time to just quickly share your thoughts on this. Now, with this said, let's move on to the main subject of the presentation. So the next generation floating mount and PCB connector called Intercompact was designed in collaboration with a major global OEM from the rail industry. Now, when we speak with similar companies from the rail industry, we hear the trends of use of technology to move from what used to be known as the break and then fix to predict and prevent. And that trend is well underway. And a few examples of how they have expressed their views, again, when we discuss this with our customers, in the way they express their view. If you look at the extreme bottom, the way typically expressed is they want to move away from the break and then fix model towards taking a more proactive and preventative or predictive and preventative approach to managing their network assets. If you look on the left, they say things like they want to improve and their onboard monitoring system of the trains equipped with connected sensors. Just above that, someone said Sensors installed on assets and rolling stock continuously feed data and increase processing power, enabling speedy processing of the information. On the right, you see someone made a comment. Conventional signals have been replaced with train-borne computers that communicate with a central system to calculate their required speed and braking curve. Then you see save money, increase capacity, eliminate the passenger's worst nightmare, and unplanned delay or service cancellation. So the reason I walked you through in the way I kind of started with the break then fix to a more predict and prevent model, and then gradually walked you through towards the right to this concept of save money, increase capacity, and eliminate the passenger's worst nightmare is because in some ways the break then fix to a predictive model is in some way a vision, is an approach. And then you walk your way through how you should go about in doing it. Finally, to circle it back to the main reason why in this particular case, the rail customer is so passionate about, which is the passengers ultimately who are their customers in some ways, that ultimately they're all doing this for the better experience of their customers. So when you understand this and you talk to them about how they're deploying their technology, we have found time and time again, in different shape and form, they're using complex electronic systems with increased computing power to achieve this technology or to implement this technology. Why? Because as I said, ultimately they want a better experience for their customers. So in some ways they want to manage and control their trains better. They want to manage their infrastructure better or provide timely information to the customers in a better way. But if you really think about this, this concept is just not limited to train, right, or a rail industry. The deployment of sensors and then trying to extract data out of it to make a greater informed decision out of that, and then you implement the decision over to make a difference to the ultimate customer, is just not limited to the rail industry, right? The same principle can be adopted and can be taken in industrial environment, in defense environment, and even to some extent, we have other mirroring products in defense and space and aerospace that can do something similar as well. So if you're from different industry, we would absolutely love to engage with you to understand your use cases and how either this particular product fits into your application, or we can work towards in making sure that we help you with a similar product that goes into your application. So let's talk about, before we introduce this connector that we have recently launched, let us spend a little bit of time to understand this particular customer's pain points and what guided the design philosophy. And this is just to allow you to understand the context. The user was looking for a compact connectors to be used with the new electronic control unit. It's quite a complex electronic system that they were trying to come up with the next generation. The unit would need to be smaller, yet deliver greater computing power, monitor greater number of assets on the rolling stock. And some of the key points they wanted us to capture in their requirements, in our requirements document, are first and foremost the miniaturization to ensure that we are reducing the size of the connector, because, as I said, it plays a pivotal role in the architecture of the overall design. Increase the power of the connector for the size of the contact and the current rating that they were looking for. Higher density of contacts and signal with Ethernet connections. PCB connected to increase the insulation resistance level. And finally, to ensure that you do all of those things that I talked about, but ultimately you have to comply to various engineering standards. For example, the EN 45545-2 or NFF 61030 standard. These are just a couple of examples. There is a long list of other standards that we had to comply. So this was, if you like, the main pain points or the guiding principle that took the design from initial days then obviously towards the launch. So with this, let us then spend a little bit of time introducing this product, understanding what it does, and then we can spend a little bit of time in understanding some of the nuances around the architecture and aspects of the design. So what you see here is an intercompact, the next generation compact signal and Ethernet PCB connector in both floating mount and PCB configuration. The product that you see on the screen has managed to deliver quite a few things that are in some ways game changer in helping the overall architecture of design. For example, we have managed to significantly reduce the size and therefore the weight and of the connector. We have made this connector not only for managing standard signals, but also for high-speed data transmission. One of the particularly versatile aspect of this particular product is that the configuration of this is quite flexible. You can use it either in floating mount option, or you can use this as a soldered for PCB connection. And finally, you get all of these things packed in a quite a compact body, but ultimately complying to various industry standards. So let's spend a little bit of time in kind of doing an exploded view of how this connector looks like before we come back to this topic again. So what you see here on the left is the connector which has got with two Ethernet connections and 42 signal connectors, signal pins. And the one that you see on the right is a complete 60 pin for signal connectors. So these are the two different variants. Now, the one on the left, from an Ethernet standpoint, can come in either one or two Ethernet contacts. As I said, this particular connector has managed to pull a lot of different areas of innovation, ultimately contributing to the greater good of the overall vision our initial customer had from an overall architecture standpoint. Now, with this said, and with this high-level introduction, let's spend a little bit of time in delving deeper into the product, understanding some of the key areas of the specification, before we again zoom out, trying to understand where this connector sits and some of the nuances around the connectors and the connections that come with it. So in terms of the some of the key achievements, now we understand, as I said, that the user has managed to reduce 30% of the overall system architecture by implementing a connector of this nature. Now, this is a significant achievement from their perspective, because you think about a rail application, a train. Now, in this day and age where we are all being encouraged to take train journeys, particularly for shorter journeys, trains are becoming overcrowded. So better information about train availability, or even kind of reducing the size of these cabinets and then perhaps extending the space for seating can massively help, excuse me, can massively help the overall cause of this particular major rail OEM. Not to mention about the high-speed connectivity that we have managed to implement, and also the compliance aspect of it, in particularly with the use of some innovative material, the improved creepage and clearance distances that we have managed to achieve. And finally, the versatility of the product really comes in ways of the floating mount or as a PCB mount configuration. So when you look into some of the detailed specification, again, it's quite a busy slide. So I'm not necessarily going to go through every aspect of it, but I'm going to just highlight some of the key points that really helps you to understand where this product fits in terms of its use cases. So this connector has been built around the hyperboloid technology. Now, hyperboloid technology, for those who are not aware of the technology, it is a contact technology that has seen the test of time and particularly used for high reliability under shock and vibration. And this contact technology is immune to fretting and corrosion, and therefore the deterioration that you see at the back of those situations. The lower mating force, for example, the insertion and the withdrawal forces, for reduce both strain and improve serviceability, and particularly the stable contact resistance. Because remember, all of these things ultimately converge in giving you a stable contact resistance, because that is, from a contact design standpoint, that is what you're trying to achieve at the back of this. So the signal contacts are a 1.02 millimeter hypertack hyperboloid contact, each of them around 3 amperage rating. The Ethernet contact that you see on the left-hand side of the two connectors is spec'd up to Cat5e. Now, clearly see on the pictures that there are 3 rows of contacts. When it comes to the signal contacts, you can get a 60 signal way, the one on the right, or 42 signal ways, one on the left, with an option of either 2 or 1 Ethernet quadrax contact. Now, one other area that I must kind of draw your attention particularly is that you get this all packed, but when you look at the voltage requirement, it's quite high voltage actually. So that means that your power budget, you don't have to compromise with your power budget when you're dealing with a connector of this nature. In terms of the standard, as I said, this is all done at the back of meeting variety of different quite rigorous standards. You know, for example, some the cryptogen clearance distance I talked about, and then fire and smoke requirements that you have to comply for the rail industry. So this product has been tested and complies to some very rigorous international standards. I talked about the use of some innovative insulation material that helped us to achieve some of these compliances. And finally, I must say, you know, particularly those who are looking at this thinking, how does this connector apply to your use case? Remember that what we're showing you on the picture, we are not regimented to this particular configuration. We are completely open in terms of customization. And if you feel that, you know, this particular configuration doesn't quite fit your application, you want to talk to us about slightly different configuration, do reach out to us. We are open to modify the configuration to suit your use case. When it comes to the temperature range, again, must draw your attention to the specification around -55 degrees centigrade, because most of the specification of what's available out there in the market and classified as connectors for arduous application, they're typically around -40 degrees centigrade. Now, why does that -40 to -55 does make a difference? Particularly those of you who are working towards applications in either extreme, let's say, North American area or in Nordic area, the temperature does go around -55. So it is worth kind of considering that aspect of it. The pollution degree is to level 2. I talked about the hyperboloid contact. Now over here, as I said, particularly when you are designing something that is in a high vibration area, do consider the mating cycle requirements as well. Termination, as I said, is available either in PCB 90-degree PCB format or in a crimp and straight socket format as well. Now, one other aspect that we have managed to capture in the design is the practicality of trying to mate this connector, because as you can imagine, this is quite a compact connector with really kind of small diameter of contacts. So what is perfectly a conceivable use case is when you're trying to connect the two halves of the connector. Misalignment is something that is quite natural. So one of the things that we are quite proud in the way we have designed it is to allow this misalignment specification, because as I said, when you're trying to mate these two things together, which is quite fine with high density of contacts, you ought to be cognizant of the fact that a misalignment is something that can very much happen. In terms of the quadrax contact, again, perhaps a little bit of a smaller nuance for those of us who are in the world of connectors, but the way the contact has been designed, which consists of an outer shield with 4 inner paired connectors forming 100 ohms, control impedance for differential pairs, is something that genuinely helps you to manage the performance of the of this connector, of this contact, quite with great confidence. The contact is up to Cat 5e, but as you know, it doesn't. If you're working towards another application which requires higher data rate, then again, please reach out to us. We are openly discussing that sort of application with a few other customers. So I'm more than happy to take into account your areas, your use cases, and try to expand the data rate of these contacts through these contacts. So that was a quick overview of the product's specification. So let's not spend a little bit of time in understanding some of the other nuances of where the product works around. So miniaturization. Now, this is one of our favorite topic, because obviously, you know, one of the things that we always try to do with the next generation is that how do we make this even smaller whilst improving the rest of the design. Now, over the years, we have witnessed complex electronic system becoming crowded with networks of multiple cables, and perhaps the picture on the left is a nice representation of the reality that we live in. Now, we recommend where it is possible to reduce the number of cable assemblies with direct PCB connection. Now, direct connection on a PCB allows you to delete one interconnection level, contributing to a space, savings of space, and then all the collateral benefits that come with it. For example, reduction of weight, resulting in the overall reduction of the size of the equipment that you were designing, and the final, the overall architecture, therefore, that comes with it. Now, while designing the next generation that respects this overall architecture goal to reduce size and all the collateral benefits that we talked about, we have to be mindful of what I talked about of the creepage and clearance distances. Because remember that just reducing it is not good enough. Any incorrect specification around that creepage and clearance distances would result in the failure of the dielectric breakdown voltage over the lifetime of the connector. So I suppose the icing on the cake for us was not only to reduce this, but to ultimately comply with the overall specification requirements from a creepage and clearance distance perspective. Another area that I want to touch upon is the contact design consideration required for high-speed data transmission, because again, this is quite a finer detail that often gets overlooked, because not everyone, but a lot of people we talk to kind of work around the concept of whether it's Cat 5e or Cat 6, so on and so forth. But when we are looking into this, we are looking into from a different lens, if you like. We are looking into how we can design the contact to make sure that not only you get the high data rate that you're after, but making sure that the reliability of the contact is robust enough for you to give a reliable connection for high data rate. Now, EMI is another key aspect when we are looking into this. And one has to make sure that their system is compatible with the communication system. For example, in case of rail, the signaling system. EMI is strongly related to earthing methods because the current passing through the earth connections can be directed by high-frequency harmonics and produce high-frequency electromagnetic fields. Now, to reduce maintenance and electrical failures, cable fixing is necessary even for high-speed cables and can be achieved thanks to the robust cable clamp system that allows to effectively connect the ground shielding to high-speed contact. Now, for example, in electromagnetic compatibility of an auxiliary power electronic system of a use case that we came across in London Underground, there can be multiple ways that that can be generated. For example, in signaling interface, in magnetic fields, for example, coming out of telephone interfaces or radiated radio frequency emissions, or your radio frequency interface immunity. Now, good EMC connection is achieved with the shielding connection over 360 degree with low ground contact resistance. And obviously, to secure the signal and the contact resistance and avoiding, most importantly, because again, we're all doing this for one overall good cause, that we're not only designing something for the high-speed data, but ultimately making sure that no one loses data at the back of this. It is very important. Therefore, you select the robust and reliable contact design for connectors of this nature. And one of the things we have to remember is the operational failure consideration, particularly when you're looking into high-speed data transmission. In our case, what we have done is that we have tested the connector to EN 61373 standard, considering more severe conditions, because we have to remember that connectors testing should comply with category level 2, including any insulation simulation, particularly in this case on bogies. The products in this case were submitted for rail qualification program and tested accordingly. Now, the RF performance, attenuation, return losses, and crosstalks were all checked during the qualification program. So in some ways, what we were trying to do is that we were not only taking care of the customer's overall use cases, but we were translating those use cases to different failure modes and the effect that might have through the connector to their overall cause, and design something that ultimately helps to deliver a reliable, a robust design with a reliable connectivity. Now, with that, I just wanted to, before we share some more of case studies, it might be worth opening up another poll around what we have talked about. And I request Katie again to kindly jump in and just walk us through that next poll, please. Yeah.
All right, thank you, Jodip. So yes, we have another polling question for you right now. As we did with the one before, I'm going to read the question and give you some time to answer, and then we will share the results. So the question on this one is, when considering the next generation of complex electronic systems, which of the following technical features has the priority for the development of your new design? And your choices are A, miniaturization, B, increased power requirement, or C, higher speed data transmission. So I'm going to put those options up for you now. If everybody could take a minute to choose your answer, I will give you some time to do that. All right, everyone, please choose your answer and submit it. I'll give you another couple seconds to do that now. All right, thank you everybody for participating. We are going to move into sharing the results right now. So I'm going to pass things back over to Joydeep to go over some of the results. And here are our results. All right, so back to you.
Yeah, interesting. This is the reason I say interesting is because this is a clear divide, as you can see, that there is no one monopoly around this topic, because in some ways each of these areas are in some way important to the particular use case that we are dealing with. So no, thank you for your input to this. And in some ways, we are looking into both particularly the miniaturization and the high-speed data transmission quite regularly for the next generation product. And as I said, particularly those who amongst, in this audience, if you like, look into this product and think, hang on, from a data transmission standpoint, you're looking for a higher data rate, then kindly reach out to us. We are kind of looking into that area already. Thank you. So moving on to the next one. So we have got a few case studies that we wanted to talk about, and so let's talk about firstly on a generic rail application case study before I hand it over to Davide, who is going to talk about a case study from industrial application. So this particular application is from the rail industry. The customer was developing the next generation electronic control unit for their power distribution for high-speed trains. The customer was looking for a rack and panel compact connectors. Now our solution over here was intercompact, and we were able to satisfy many of the requirements that they came up with. For example, having this option of floating mount option for receptacle connectors for blind mating. The hyperboloid contact, which I talked about, the reliability aspect of the hyperboloid contact to provide long contact life and the low insertion force. The signal and quadrax contact for high speed in the same compact connector. The insulated material that we were able to use and therefore able to comply to some of the rigorous rail standards for fire and smoke, and other key rail standards to meet insulation resistance level required. And finally, you do all of this for an improved creepage and clearance distance of the contacts, and therefore optimizing to ensure for absence of any electrical failures. So this was a nice case study from our standpoint. We worked very closely with this customer, and in some ways, we took satisfaction not only in developing this next generation, but ultimately in delivering the greater cause that they signed up to, which is to miniaturize their system. So in that way, we took great pleasures out of that engagement. Now with that, I'm going to hand over to Davide now, who can talk us through an industrial case study that he championed. Davide, over to you.
Thank you, Joydeep, to give me the opportunity to present this application. Hello, I'm Davide Borsati. I'm Sales Data Manager EMEA for Industrial and Rail Market. Graphic Control is an Italian company. They are happy to use our connector for many years, and they rely on Smith product in order to control printing process and to ensure high quality resolution in their system. For a new project, Graphic Control need to reduce the size of the rack by integrating multiple signal and power supply. In this equipment, all the boards are stressed to continuous handling and vibration. The name of the application of the customer is the Register Control System for Automatic Graphic Controlling Printing Machine, and is used to produce newspaper, magazine, and to control the process. Our 60-way and 31-way connector were selected by the customer for technical performance. One of the key points is the possibility to support up to 220 volts in high density to increase the power of the system, and for the connection of the all and O signals. The high reliability of hypertag contacts and the low meeting force of the connector were also key factors for the customer choice. Thank you for your attention. I leave Kathy to take the control and to start with the answer your question. Thanks.
Okay, thank you guys both so much for a great presentation. As David just mentioned, we are going to start taking some questions from our attendees. So our first question for today, gentlemen, do you have any hoods for this product?
I'll take that question if that's okay. Yes, we are currently in discussion with another customer for whom we are designing a hood for them. So again, if that's something one's interested in, do reach out to us. The one that we are considering is going to be a hood made out of light metal alloy. It's going to be easy to use, assemble for swivel latch. You can also have, for example, angled cable exit with 360-degree shielding is maybe an option as well to consider. So yeah, absolutely. So interesting question, and perhaps if you've got a use case around that, do reach out to us. Yeah.
All right, Jody, thank you so much for that answer. We do have a couple more questions coming in here from our attendees. The next one here is asking, rail and industrial markets apart, why should we consider this series for the space market?
So generally speaking, I suppose, as I said at the beginning, many of the parallel applications do require or try to achieve a similar objectives. Now, when we define space, there are lots of different kind of applications and use cases within it. Now, if this doesn't quite fit the bill, I must stress that from a wider portfolio standpoint, we have got quite a lot of space qualified products that mirror some of the use cases that you might be looking for. So again, worth reaching out to us, and we can work with you to identify the right connector that fits your use case and the requirements.
Okay, thank you so much for that answer. We are going to move into our next one here. This attendee is asking, there are many PCB connectors. Can you elaborate on how this is different?
That's a great question, actually. No, so let me, I'll perhaps take that question as well, if that's okay, Davide. Look, there are quite a few areas that I want to highlight. Particularly, I want to draw your attention to start with the contact design. With the, in case of the hyperboloid contact, I talked about the high reliability under shock and vibration, its immunity to freighting and corrosion, the low mating forces, and all of them somehow kind of combining to give the main objective of stable contact resistance. I also showed you a picture in one of the slides about the way the quadrax contact has been designed. So all in all, I suppose the contact design is vitally important for us to work around. And if you look into the rest of the connector, for example, the higher misalignment or from a floating arrangement standpoint, the higher voltage with the number of contacts packed in a smaller body, the PCB to PCB, and for example, rack and panel application configurations, and finally meeting all the list of the compliances. When you put all of them in one big bucket, if you like, it's genuinely very difficult to find exactly like-for-like connector out there in the market. So hence we say that this particular connector does tick a lot of different boxes, and particularly those who are looking into expanding. Again, I go back to the greater goods of the application of trying to monitor multiple assets, trying to increase computing power of your control units, then this in some way does achieve all those areas from a use case perspective. Yeah.
Okay, thank you so much for that answer. I just wanted to point out to our attendees quickly that we have some items in our resource list. There are 3 items there right below the Q&A window. If you'd like to click on those and download and take them with you today, please do that before we wrap the webinar up. All right, gentlemen, so back to our Q&A. This next person is asking, how does this connector perform outgassing criteria per EEE-INST-002?
Okay, so the honest answer to the product hasn't been tested to that standard. So we will have to look into that standard and test it to the requirements of the standard. So that is something we haven't done, and but as I said, we have launched this product quite recently. We are inviting many more use cases and applications to where this product can go into. So if this is something that's a requirement for your application, then we would want to reach out to you and have a deeper discussion, and then ultimately we will have to test the product to this standard, and then come back to you with the results. Yeah.
All right, thank you so much for that answer. Next question here. Wouldn't the position of the hypertack contact be so close to signal contact? Would that affect signal integrity without shield or grounding?
No, again, I'm obviously making a very broad answer here without being very specific. No, not necessarily, because we have tested this in the real. Obviously in our labs, but as well as in real applications, and this doesn't ring to us as something that would create or has created problem, from the applications that we have worked with so far. But again, something might require a deeper discussion to perhaps understand the pain point you are highlighting here, and make sure that your use case has been understood properly, and we have properly kind of reviewed technically. If it does, then how do we mitigate that aspect? But at a broad level, we have not come across that issue so far, and hence again, it's difficult to answer that without going into the real details of your use case and kind of map it against the product and see whether, if required, as I said, we can do further investigation to make sure that in your application, if this is something you want to position, then this doesn't become a problem for you.
Okay, great. Thank you so much for that answer. A reminder to our attendees today, if you do have a question or a comment, go ahead and place it into the Q&A window and click submit. We will do our best to answer all of our questions today. If we don't have an answer for you today, we will reach out to you following today's webinar. So next question. All right. This person is asking about something on the website. They're just looking for the dimensions and just wondering where on the website they can find information for connector heights and stack heights.
Okay, so if you go onto Smith Interconnect's website, and if you go onto the products page, if you search by the product name Intercompact Series, you will see the web page. We can perhaps share the URL of that page. And in the catalog, you can go into page number 5, where you will see the dimensions of the connectors, and we have kind of outlined all the key dimensions that one would require. So that information has been published on the website, and perhaps what we might need to do is to just share the URL with all attendees. Yeah.
All right, great. Thank you so much for that answer. So we do have another question here. If anyone else has a question, please feel free to enter it into the Q&A window and click submit at this time. You can also ask questions following the webinar, so if you do have a question that you think of later, you are able to come back and enter that in later, and we will get back to you at that time. So I think this is going to be our last question for today, gentlemen. So this question, or this attendee is asking, is intercompact IP protected? Can we add on pins if we do not want Ethernet contacts?
In some ways, the architecture product has been defined in the way it has been defined. We cannot we can play around the configuration in case of a 60 ways. For example, if you don't have need all the 60, then you can obviously reach out to us and we can work around it. But in essence, the architecture is what the architecture of the connector is. We can play around to work or to map against the use cases and play around the number of pins on the connector side. Yeah.
All right, Joe. Thank you so much for that last answer. So we are going to move into wrapping this webinar up right now. So I want to say a huge thank you to David and Joydip for being here today, for going over such great information and for sharing some case studies. So, gentlemen, I want to say a huge thank you to both of you.
Thank you.
Thank you a lot.
All right, thank you, gentlemen. And for all of our attendees, we do have those items in the resource widget for you to take with you today. If you haven't already taken a look at those, please do so now. They are listed right below the Q&A window. We also have a survey that is along the bottom of your webinar console in the survey widget. It's going to pop onto your screen at the end of this webinar. We would love for you to take a moment to fill that out. Your information is very important to us, and we value your opinions. So please share any comments or questions and fill out that form for us so that we can make all of our webinars better. And you will be receiving an email from us with a link to the on-demand version of this presentation. You will be able to come back and watch this again or even share it with colleagues. And lastly, like I mentioned, please take a moment to complete that survey, which will appear on your screen. As I mentioned, if you are watching this later on our on-demand, you will find that survey located along the bottom of the attendee console in the widget. Again, I want to say a huge thank you for everyone taking time to attend this webinar event. If you have any last-minute questions, you can enter them now, and we will reach out to you following the webinar. Again, thank you all for taking time to be here. Take care, and we will speak with all of you soon.